Just after 1:30 in the morning on June 3rd, the sun released more energy in a few minutes than humanity has produced in its entire history, and we caught it. This is the sun, photographed by NASA's Solar Dynamics Observatory, not in visible light, but in extreme ultraviolet at 193 angstroms. That wavelength shows plasma heated to around 1.5 million degrees. Every one of those swirling bright threads you see is a loop of superheated gas bigger than Earth, held in shape by magnetic fields. The sun does this constantly. We just usually don't notice. Now look here. See that bright, tangled cluster toward the center right of the frame? That's close to where active region 14455 sits, at a position astronomers tag as M9.3, meaning 13 degrees north of the solar equator, just slightly west of center as seen from Earth. At 1:36 in the morning, UTC, that region erupted with an M9.3 class flare. M class is the second strongest category. An M9.3 is right at the edge of the next level up. The X class. It came very close. Now look over to the right side of the disk. See that glowing rim where plasma is arcing off the edge? That's the limb, the sun's horizon from our point of view. When a flare fires, it doesn't just light up. It can throw a billion-ton cloud of charged particles outward at 1,000,000 miles per hour. That's called a coronal mass ejection, or CME. Whether this flare launched one toward Earth is something forecasters at the Space Weather Prediction Center were calculating within hours of the peak. And then there's the dark patch sitting at the bottom of the frame. That's a coronal hole. Magnetic field lines there are open, shooting solar wind straight out into space rather than looping back. It's not dangerous on its own, but it's a reminder that the sun isn't a simple glowing ball. It's a churning, magnetic, unpredictable system. And right now, in 2026, we're near the peak of solar cycle 25. More of this is coming. One flare, a few minutes, energy we can barely put a number on. And the whole thing was caught by a spacecraft 93 million miles away, beaming back images every 12 seconds. The sun has always done this. We just recently learned how to watch. We'll be here tomorrow with whatever the data shows next. Subscribe so you don't have to remember to come back.